Today I'm going to give you a brief introduction to the idea of functions. We haven't used this word function yet, but we've talked a lot about things that are functions. So I'm going to start by giving you a definition. I have it typed up on my notes. A function is a relationship between variables where every input corresponds to exactly one output. You can also think of a function as a mapping. It basically takes your set of x's or your inputs and it maps them or transforms them to a new set of outputs or y values. Now that definition is saying that if you have an x value, an input, it can only be mapped to one y value. So let's illustrate this by just looking at example 1. There are two tables of values, and we want to know, are these functions? In the first table, every single x gets mapped to only one y value. It's okay that some of the y values are the same. The idea is if I give you an input, x equals 3, there's only one y value that goes with it. So this first table is a function. However, in the second table, notice x equals 1 actually corresponds to two different y values. X equals 1 could be mapped to 5 or 0. That means the second table of values is not a function. So it's okay to have the same y value. It's not okay to have the same x value appear in your table. Now what if we want to determine if a graph is a function? We can actually do the exact same thing graphically. If I pick an x value, for example x equals 1, on this first graph I can see that there is only one point, one y value, that corresponds with an x value of 1. If I pick another x value like x equals 2, same thing, there's only one point, one output, that has that input of 2. That means this first graph is a function. Now if I look at the second graph, and I do the exact same thing, I pick an x value like x equals 1, I can now see that there's two different outputs, two different points, that have that same x value. So the second graph is not a function. We can summarize this idea as something called the vertical line test, which basically says a vertical line can cross the graph of a function at most one time. So if I look at that third example and draw some vertical lines, they cross the graph only once, so yes, it's a function. Now when we talk about equations of functions, we're going to start to use a new notation called function notation, where rather than using the letter y for our outputs, we're going to use the symbol f of x for the outputs. We're going to be replacing all of the y's with f of x. So let's practice using our function notation. In example 3, we have the function f of x equals 3x minus 7. That equation is equivalent to y equals 3x minus 7. Instead of the y, we have the f of x. Part A is asking us to find f of 0. In other words, they're asking us to find the output, find y, when the input, the x, is 0. The thing inside the parentheses with function notation is always the input. It's always what you plug in for x. So to find f of 0, I would replace the x with 0. 3 times 0 minus 7 is negative 7. F of 0 equals negative 7 means when x is 0, y is negative 7. We can do the exact same thing with the next two problems. If I plug in negative 1, 3 times negative 1 minus 7 is negative 10. So when x is negative 1, the y value is negative 10. Finally, for part C, we do the exact same thing. To find f of 4, I plug in 4 for x. That gives me 12 minus 7, or 5. So when x is 4, y is 5. Now part D is a little bit different. It's asking us to find the x. So for what values of x do we get an output of 2? When does f of x equal 2? To solve this problem, I'm going to plug the 2 in for the f of x, for the output, or the y. And then I have an equation that I could solve for x. Add the 7, divide by 3. So the answer is x equals 3, or in function notation we could say f of 3 is 2. When the input is 3, the output is 2. We can answer similar questions using tables and graphs. And so if I want to use the following table of values to find f of 5 and f of 1, well, let's start with f of 5. The thing to remember is that the thing inside the parentheses is always the input, or the x. So to find f of 5, I'm basically asking you what is the output, what is y, when x equals 5. I can see in my table of values that if the input is 5, the output is 6, so f of 5 equals 6. I do the exact same thing to find f of 1. If the input or the x is 1, the output is negative 4. If we're given a graph, the idea is the same. The thing inside the parentheses is the input or the x. We are trying to find the output or the y. Part A, find f of 0, is asking us what is y when x equals 0. So I go to my graph and I find the point that has an x value of 0. That point has a y value of negative 3. So f of 0 is negative 3. To find f of 1, I go to x equal 1, I find the point with an x value of 1, and I read off the y value. The y value of that point is negative 2. F of negative 2, my input is negative 2, my x is negative 2, I go to the graph. The point that has an x value of negative 2 has a y value of 1. And finally, f of 2, the point on the graph with an x value of 2 also has a y value of 1. So to summarize, in all of these problems, the thing to remember is whatever's inside those parentheses is your x value. When you put that f in front of it, f of 0, f of 1, I'm asking you to find the output that goes with that input. The next thing we're going to do in this section is talk about how we can graph functions. Now remember, the f of x is just a y, so the function f of x equals 2x minus 3 is actually a linear function. This function is in slope-intercept form. Slope would be the number in front of the x, 2 over 1. The y-intercept is negative 3. So to graph, I start by plotting the y-intercept, negative 3. And since the slope is 2 over 1, we can go up 2 over 1. And then connect the dots to get a very nice graph of that line. So linear functions, we can always use the slope and the y-intercept to graph. What about nonlinear functions? F of x equals x squared is the equation y equals x squared. When we have nonlinear functions, we are going to make a table of values. So I'm going to pick just a bunch of x's, some negative, some positive, and I'm going to take these x's and plug them in. So if x is negative 2, x squared is 4, so y is 4. If I plug in negative 1, negative 1 squared is 1, and I can do the same thing with the rest of those x values. 0 squared is 0, 1 squared is 1, 2 squared is 4. Now I'm going to go through and plot all of those points in my table of values, putting them onto my graph paper. And if I connect the dots, I get something with kind of a U shape to it. We call that shape a parabola, and in fact, anytime you have a quadratic function, something with an x squared, you can always expect to see this parabola shape. It might be upside down, but you'll always see the same basic shape. Let's do one more graph. F of x is absolute value of x minus 2. I'm going to do the exact same thing. I'm going to make a table of values, plug some numbers in, and see what happens. I put quite a few x's in my table of values because I want to show you what the shape of this graph is. But once we have an idea of what the shape is going to look like, we won't need quite so many points. If I plug in negative 2, absolute value of minus 2 is absolute value of negative 4, or 4. I plug in negative 1. Negative 1 minus 2 is negative 3, and absolute value of negative 3 is 3. And I do the exact same thing for the rest of the x values given. I plug in the x value, do the subtraction, and then take the absolute value. To finish, I'm going to plot all these points on my graph paper. And then we can connect the dots. And we should get something that has this V shape to it. You will always see this basic V shape when you graph an absolute value. So having an idea of what shape you expect means you can plot fewer points. So again, quadratics, things with x squareds, are always parabolas, and absolute value functions always look like these. We're going to continue our discussion of functions in the next video, but let me know if you have any questions.